Now, am I audible clearly?
Yes, sir.
Okay. Okay. Now, in last lecture, what we have seen the VHDL design for the combinational logics, right? So now we are going to start with the VHDL designs for the sequential logics. Now, I hope you have uh, clarity in your mind what is combinational logic and what is sequential logic, right? You have clear with this. Now, we will start with the first design, that is flip-flop. Okay. So what do you mean by flip-flop? There are different types of flip-flops that you have studied: D flip-flop, then SR flip-flop, right? JK flip-flop and toggle flip-flop, T flip-flop. So flip-flop is basically a storing device which can able to store the data, and whenever it triggers, it can pass the data, or it can able to output the data. That is the flip-flop, right? Now, this is the symbol for D flip-flop and its truth table. Whenever you will trigger the clock pulse, right, whatever the input, it will get reflected to the output. Okay. So this is the D input, Q is the output. So whenever there is a presence of clock pulse, whenever you will apply a positive age clock pulse, what will happen? It will output the data which is input to it. Okay. So this is the D flip flop. Now, what about JK flip flop? So basically, JK flip flop is a combination of SR and T flip flop, right? So if you combine the SR flip flop with toggle, then you will get the JK flip flop. So it has two different states, J, K, and the clock pulse. What is truth table for the JK flip flop? So for these J and K inputs, these are the probable output states that you will get into. So for 0, 0, that means J0, K0, the output, that is Qn plus 1, it will be Qn, right? That means present. Then for J is 0, K is 1, you will get 0 as an output. Then for J is 1, K is 0, you will get 1 as a output, and again for 1 1, that means J is 1, K is 1, you will get Qn as output. Okay, this is about the JK flip flop. Now what is toggle flip flop? This is the T flip flop. Whatever the input, the output will be exactly the opposite of the input, that means the toggle state. Okay, that means if T is 0, it is the exactly opposite of the input whatever, and if T is 1, it is again exactly opposite of the input. This is the T flip flop, toggle flip flop. Now we are going to study the VHDL code for this individual flip flop. Okay, now we will study first for the D flip flop. So this is the library part. Now again, you can see here in the library, we have included these two extra packages, and why it is required? As in case of flip flop, we may use some arithmetic operations. So we require this standard underscore logic underscore arith package, and also in case of this flip flop, we require some unsigned data also. That's why we require this standard underscore logic underscore unsigned, right? This is the library, and these are the packages in this library, and that we have used here. So first entity DF, that is the D flip flop, then port D clock, these are the inputs, and Q is the output. Okay, this is the entity part. Now this is the architecture part. So what about this architecture? So architecture behavioral of DF is begin, then process clock. Okay, we have used the process statement, so of course it's a behavioral style of modeling. Then process clock, then begin. Now this if else condition we have used here. If clock is equal to 1 and clock tick events happen, that means what? we have applied a clock and there is a clock tick event, then the Q, that means output, will get the input. That means Q will get the D. And if, and process, and behavioral. Right? This is very simple code for D flip flop. We have used if else statement and process statement. That means everything is depend upon clock. If there is a clock, then you will, if the input will get transferred to the output, and if there is no clock, it will hold the input data unless and until you will provide a clock pulse. Okay, so this is about the D flip flop. Now next one is T flip flop, toggle flip flop. So again, this is the library part. Library IEEE use standard underscore logic underscore 1164. This is the common library that we can use. This is the entity part. Okay, for toggle flip flop, how many inputs outputs we will require? So T and clock, these are the inputs, and Q is the output. Okay, and this is the architecture part. So here we have defined this signal temp, then it is of standard logic mode or standard logic data type, then begin, then process, then clock. Okay, then if clock tick event and clock is equal to 1, then again we have mentioned another condition. If t is equal to 0, then temp will receive the temp, else t is equal to 1, then temp will receive not of temp. That means exactly opposite of that. Means there is a no clock pulse, it will transfer the as it is input. And if there is a clock pulse, then it will toggle the input, and it not of temp means what? Exactly opposite. If temp is 0, then not of temp, and if temp is 1, then again not of temp. The and if and process, and finally after this process, as we have declared the signal temp, and we have to get back that signal value into our original output. What is our original output? This Q. This signal is temporary, we have defined here. Right? This signal is temporary, we have defined here. So this Q signal temp output, this temp, and we have to get back this temp value into our original output. So after end of process, temp will get transferred to the original output Q and behavioral. So this is also a simple program for T flip flop. Now we will talk about the JK flip flop. Okay, so what about this JK flip flop? So again, we have to define the library part. So this is the library part, standard underscore logic 1164, then arith and unsigned. These packages we are using here. Okay, then entity part we have defined here, port, JK, clock, Q and QB. This is the next stage. So these three are the input, these two are the outputs, right? So architecture part, this is the architecture part. See, always remember, we have studied the different VHDL codes for the combinational logic. Okay, structure will be always same. First you have to define library, then you have to define entity, and then you have to define the architecture. So these are the very standard structure for any VHDL code. First there should be a library part, then there should be an entity part, and then there should be a architecture part. So in architecture you can use any style of modeling. You can uh, write that architecture part with the help of data flow or behavioral or structural. Okay, so you have some set of concurrent statements, you have some set of sequential statements, so accordingly you can use that statement. Okay, in the respective style. But normally what we are doing in case of behavioral style, we are using the process statement. It's a backbone, or you can say basic building, or the basic command of the behavioral modeling is the process. In case of data flow, we are simply uh, writing a logical equations that we have derived from the k-map, that is the mostly data flow, and some when else statement or case statement. And in case of structural style of modeling, the port map is the basic building block, right? Without port map, it is difficult to write the structural style of modeling. Okay, now architecture behavioral is begin, then process clock. Again, we have defined here variable. See, you can see the difference. Here we have defined the signal. Where we have defined signal? Before begin. बघा आपण इथं सिग्नल कुठे डिफाईन केलाय? बिगिन स्टेटमेंटच्या आधी. पण व्हेरिएबल आपण इथे डिफाईन केले ते कुठे डिफाईन केले? आफ्टर बिगिन स्टेटमेंट. सी, आफ्टर बिगिन देर इज अ प्रोसेस, आफ्टर प्रोसेस देर इज अ व्हेरिएबल, right? And of course, as variable is very locally used, its value cannot be passed outside the process, and that's why we have transferred the variable value before end of process. But in case of signal, you can see here we have transferred the signal value after process statement. एंड प्रोसेस केल्यानंतर पण आपण सिग्नलची व्हॅल्यू पास केली. कुठं? सिग्नलच्या केसमध्ये. आणि सिग्नल डिफाईन पण कुठे केलाय? बिफोर प्रोसेस स्टेटमेंट. बरोबर आहे? प्रोसेस स्टेटमेंटच्या आधी सिग्नल डिफाईन करायचा आणि प्रोसेस स्टेटमेंटच्या नंतर त्याची व्हॅल्यू पास करायची. बट इन केस ऑफ व्हेरिएबल, यू हॅव टू डिफाईन दिस व्हेरिएबल आफ्टर प्रोसेस स्टेटमेंट, and before process statement its value should be passed to the respective output. Okay, so this is difference between the signal and variable. Okay, now this is about JK flip flop. Process, then variable temp we have defined after. If clock tick event and clock is equal to 1, that means when there is a clock pulse. Then again, if J is 0, K is 0, then temp will assign to the temp value. Else if when J is 1, K is 1, then also temp will get not of temp. And for rest of the two conditions, that means when J is 0, K is 1, then temp will be 0, else temp will be 1. For which condition it is 1? J is 1 and K is 0. That means the remaining last condition, temp will be 1. Okay, now this is a temporary variable, but what is our expected output? Q and QB. Now this temporary value of this variable temp we have to pass to the actual output. We have to pass to the actual output. So we have passed this value before we are ending the process, right? We have passed variable value before ending the process, right? So this Q will get temp and QB will get not of temp. That means before ending the process, we have passed the variable value to the respective output. Okay, so this is about the combinational logics of flip-flops D type, T type and JK flip-flop. Okay, now next part that we are going to study is the 4-bit shift register. Okay, next part that we are going to study is the 4-bit shift register. So what do you mean by 4-bit shift registers? So this is the block diagram for 4-bit shift register. So you have 4 D flip-flops connected serially. Then you can give input, and based on the application of clock pulse, each input will transfer to the next flip-flop, then next flip-flop, then next flip-flop, and it will shift accordingly per one clock pulse. That means for each application of a single clock pulse, the data of flip-flop will get changed by 1. That means by 1 means what? The first flip-flop will transfer data into the next flip-flop after application of each clock pulse. This is the shift register, right? It will shift data into the next one after application of clock pulse, right? This is called as shift register, 4-bit shift register. So this is a very simple block diagram of this, and normally D-type flip-flop you can use, as it's a very good quality to transfer a data into another flip-flop. So this is the about shift register. Now based on this, there are certain combinations of shift register. That means you can parallelly input data, parallelly you can take the output data. This is the first condition, that is parallel in, parallel out. That means input also you will input the data parallelly, and you are taking the data out of the flip-flop, that is also parallelly. This is the first case. Next case is what? You can input the data parallelly, but you can output the data serially. This is the second combination. Parallel in, serial out. This is the second combination. Now, third combination is what? You can serially input data and also you can serially take the output from that flip-flop. That means serial in, serial out. Input also you are sending or you are feeding data serially, you are taking data serially. Serial in, serial out. This is the third case. And last combination is you can input data serially, that means serial in, but you can take data out parallelly. You can take data out parallelly. So serial in, parallel out. Serial in, parallel out. Okay, this is the fourth condition. So this is about the shift register, and we are going to discuss its VHDL code in the next lecture for this parallel in, parallel out, and serial in, serial out. Okay, so this part we will cover in the next lecture, but I hope you have understood the concept of shift register. Okay, you can input data serially, you can output data parallelly, or you can take data out parallelly out. Then this is the serial in, parallel out, then serial in, serial out, then parallel in, parallel out, and parallel in, serial out. These four different combinations. In that four different combinations you can operate the shift register. Okay, so this is all about today's lecture. If you have any doubt or query, you can ask me right now, or else we can stop here.